Okay, so now you should be able to see something. Okay, give me a thumbs up if you guys can see my screen now. If you can see my screen up here, just let me know if you can see now what's going down on my screen. I think I already opened this. Let's see. Do I need this? Okay, I can leave that there. Right, awesome stuff. Okay, let me see what you're saying in the chat. I hope that's confirmation you can see on my screen. Yes, okay, great. Glad to hear it. All right, guys. All right, so glad to have you on the line. All right, today we just want to go through the theory side of business calculations, unit 2, okay? And I think you guys are going to be going through your test. It should be the second week of April. So after this long weekend, I see you again next week. And then the week after that, you should be writing your test too. Okay, but one session will be more than enough for us. And good part is I get to see you face to face as well. Okay, so unit 2 is working with non-integers, percentages, ratios, and proportions. Okay. Okay, integers. What are integers? Integers are positive or negative whole numbers. Okay, so they are whole numbers that can be either positive or negative. They are never fractions or mixed numbers. Okay, integers are always whole numbers. And then non-integers, all right, that's where you'll then have fractions, decimal numbers, and the like. Okay, then percentages, ratios, and proportions are mathematical conversions that are often deployed in the business world. Okay, so these are highly relevant things, both integers and non-integers. Okay, right. Then working with fractions. All right, a fraction is written as follows. You have a numerator and you have a denominator. All right, the numerator is the one that we have on top, then the denominator is the one that we have at the bottom. The denominator indicates the number of parts into which something is divided, and the numerator indicates how many of the denominator is used. Okay, so basically, if you're thinking a pizza has got 8 slices, okay, it's got 8 slices. Now, if we say we've eaten 3/8 of the pizza, it shows us that 3 pieces out of the 8 have been eaten. So in other words, we have 5 out of 8 remaining. Okay, so it shows you how much of the full portion, all right, has been eaten and how much of the full portion still remains. Okay, that's what the function of the numerator is. All right, then we speak to equivalent fractions. All right, now equivalent fractions are basically fractions that are equal to each other, but are obviously not written in the same numerator and denominator. Okay, they're written. So here we have an example. We have different fractions that are equal in value. Okay, so we have 1/2, which is half, right? And then 2/4, which is also half. Okay, but can you see this has 4 pieces, this has 2 pieces only. Okay, then we have 4/8, which is also half. And we could go on and on and on. We could go 16/32. All right, we could go 8/16. All right, we could literally go on and on and on. Okay, right. Then we have proper and improper fractions. Okay, proper fractions is where the numerator is less than the denominator. Okay, so these fractions that we've been looking at so far are all proper fractions, okay, where the numerator is less than the denominator. Then improper fractions. Improper fractions, the numerator is greater. That's why it's improper. The numerator is greater than that of the denominator. So it's like saying we have 9 pieces of a pizza. Okay, how do you have more slices of pizza than the number of pizza slices that you should have in a pizza box? Okay, that's improper. Okay, think of it like that. Then we have mixed fractions. Mixed fractions, what's happening with a mixed fraction? There we have a whole number and a fraction together. Okay, so you could say 1.5. Okay, 1 2/4, 6 7/8. Okay, that's what we call a mixed fraction. Okay, then we move on to addition and subtraction of fractions. We move on to additions and subtraction of fractions. Okay, right. So with addition and subtraction of fractions, how do we actually go about addition and subtraction of fractions? Okay, so remember, if I'm to give you an illustration, we can have 5/8 plus, let's say, 5 as your denominator and 8 as your numerator. How do we add these two fractions? Can somebody tell me there in the chat what must happen? How do we add these two? Somebody tell me there in the chat. How do we add those two fractions? Actually, we can close this. How do we add these two fractions? Come, guys. What must happen before we can add these two fractions? What must happen? Yes, thank you very much, Apiwe. The base must be the same. Okay, so in order to get the same base, what we then need to do is multiply these two denominators. Okay, so 5 times 8 or 8 times 5 is going to give you 40. Okay, then once you have that, what you then need to say is, okay, since we times this 8 by 40, we then now, this 8 times 5, we then now need to times this 5 by 5 to give you 25. And then you need to add that and say, okay, since this 5 was times by 8 to give you 40, we need to say 8 times 8. Okay, and that I don't know off the top of my head. So we need to quickly pull out our calculators. So 8 times 8 equals 64. So this becomes 64. Okay, and 64 plus 25, what do we get? Plus 25, we get 89. All right, so it's going to be 89 divided by 40. That's the answer to the question here. Okay, 89 divided by 40. Okay, what about when we have to subtract? So let's say subtract 3/12. What must happen over here? What must happen over here? Again, we need the same base. We need the same base. So how do we do this? What base can we use? What number does 8 and 12 both go into? Somebody tell me there in the chat. What number does 8 and 12 both go into? 24. Thank you again, Apiwe. 24 goes into both. Oh, sorry, 8 and 12 both go into 24. All right, so here we can put 24 as our base. Okay, so 8 into 24 is 3. So here we say 5 times 3, we get 15. Okay, minus 12 into 24, we get 2. So 6 times 2, we get, sorry, 3 times 2, we get 6. All right, so then what is our final answer? Our final answer is going to then be 9 over 24. Okay, and can we divide this by 3? Yes, we can. So we can leave this in its simplest. This is going to be 3 over 8. Okay. Oh, 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 but yes, I get the 9 from 6 minus 15, or 15 minus 6. I'm not sure if I understand you right. Or do you mean over here, saying that should be 9 and not 6? Because remember, 12 into is 2, so 3 times 2 gets 6. 3 times 3. Why are we saying 3 times 3? It's supposed to be 2 times 3, because remember, 24 divided by 12, you get 2. So this should be times 2, because that is times 2. Ah, no problem up here. It's all good. It's all good. Okay. Right. Happiness. We're all on the same page. Okay. So yes, your final answer should be 3 divided by 8. Okay. So that's typically how you need to then do your subtraction and addition when it comes to fractions. You need to put them into the same base. Okay. Then we talk about multiplication. Multiplication of fractions. So here we can say 8 divided by, let's say, 10 times, let's say this is 5 divided by 8. So multiplication is pretty straightforward. It's rather easy. What you need to do is to simplify or divide these. Say 8 can get into 8, so that's 1 over there, 1 over there. And then 5 here, 1. And then 5 into 10 is 2. So then when you times say 1 times 1, you get 1. 2 times 1, you get 2. All right? You get a half. Okay, and you are done. Okay? So that's multiplication. You just need to simplify first, and then you multiply. Okay? All right. Alternatively, what you can do is you can multiply first and then simplify thereafter. So if we say 8 times 5, we get 40. Say 8 times 10, we get 80. Okay? But then again, we need to leave it in its simplest. So 40 into 40, you get 1. 40 into 80, you get 2. Okay? So it's just easiest to do that immediately as opposed to doing it later. Okay? All right. So that is your multiplication. Okay? Then we get division. Division. So let's use the same one. 8 divided by 10 divided by 5 over 8. Okay? So when it comes to division, all that you do is you just inverse this second fraction. Okay? You just invert it. So you then say 8 over 10 times 8 over 5. Okay? All right? So here you can divide by 2, you're going to get 4. Here you can divide by 2, you're going to get 5. So 5 times 5, you get 25. 4 times 8, should get 32. Okay? And this you can't simplify. Okay? All right? And that's going to be your final answer. All right. That is that. Okay. Then working with decimal numbers. Okay, if we turn to page 60 in your textbooks, let's see what's going on over there. Let's see what's happening over there. Page 60. Oh, got the wrong textbook out here. Let me quickly get the right one. Okay, so page 60. What's going on page 60? Let's see. Let's see. Working with decimals. All right, so there you can see it's actually page 61. There you see convert the following fraction into decimals. Okay. So there, the first one that they've given us is 4 and 3/8. Okay. So literally all you need to do is punch this portion into your calculator. Once you punch that into the calculator, I think over 8, this is 12.5. So 3 times 12.5, 3 times 12, you get 36. And then 3 times that half, you're going to get 0.37.5. And then plus the 4, this is then going to become 4.37.5. Okay. So in other words, 4.375. That's your final answer. Putting it in decimal numbers. Okay. So it's pretty simple. All you need to do is to divide the fraction in your calculator, and then you will get the decimal number. Same principle with this 7/250. Okay, let me pull out this calculator. Okay, so we say 7 divided by 250. What do we get? Okay, as a decimal, that's going to be 0.028. Okay, and we'll do some of these things together in class when I see you next week. Okay, but now, as I said, we want to just do the theory side to it all. All right, converting fractions to decimals. Oh, that's page 61. What have we been doing right now? Working with decimal numbers. Okay. So there's just pretty much explaining the places. All right. It's just explaining the places. So if we look 0.1, this is a tenth. Okay. All right. Then, all right, this is going to be 100th. Okay. This is going to be 1,000. Okay. Okay, and so forth, so forth, so forth. Okay, that's pretty much what they just want to highlight there. Whenever we want to turn a full number into a decimal, depending on where it is on this, if it's 250, okay, we then divide by 1,000. Okay, depending on how many zeros, how many placeholders it has. Okay, so that's pretty much just working with decimals. Okay, right. Cool. So we've pretty much covered this as well, converting fractions into decimals. That's what we've been doing, what we initially did. Then here we're talking about non-terminating and terminating and reoccurring decimals. Okay, non-terminating is where we have this 0.3333, and it just keeps on going. That's what we call reoccurring. All right, or should I say, or non-terminating. It's pretty much the same thing. Terminating, however, is where we have 0.25 and it ends there. Okay, here they say non-terminating is an answer that goes on and on, never ends. Okay, terminating is a decimal that is exact, all right, and complete, as you saw over here. That is exact and complete. Reoccurring is one in which the last decimal digit is repeated over and over again. Okay, so you can get a non-terminating, all right, which would then you would then find maybe, for example, if you go 1.15171717 like that. But when it comes to recurring, it's literally 0.66666 like that. All right. So yeah. Okay, let's move forward. Converting decimals to fractions. We can convert any decimal to a fraction, but by first determining the place value of the last digit, okay, to the number and using that number as the denominator of the fraction. Converting decimals to fractions. Okay. The digits of the decimal become the numerator of the fraction. So here we're basically saying if you give me a decimal, so for instance 0.33, okay, or we can even make it 35. Let's leave this reoccurring alone. Okay, 0.35. Literally all we then do to make this a fraction is we say, okay, we've got 1, 2 zeros, so we say 35 divided by 100. Okay, can you see how this 35 has now become the numerator? Okay, that's all that they're really trying to say over there. Okay, right, rounding off decimals. Okay, if we go to page 63, apparently the procedure is there. Okay, you guys can read through that if you want to, but for me it's fairly simple. If we have the number 0.578225, okay, literally all you need to do is to say if they want you to round off to 5 decimal place, which is here, you then look at the next number and you can see this is 5. Okay, so 5 is above 4, right? So since it's above 4, we can then make this 3. So it will then become 0.57823. Okay, can you see that's rounded off to 5 decimal place. If we wanted to round it off to 4 decimal place, once again we look at the next number, which is this 2 over here, okay, and you can see that is below 5, okay, it's 4 and below, so therefore this 2 is going to remain the same, so it would be 0.578 2. Okay, that's your answer. If we wanted to round it off to 2 decimal place, which is here, we look at the 8. So we always look at the, what do they want us to round it off to? We look at the very next number. Very next number. And this is above 5 and above. So this is going to become 0.58. Okay? 0.58. And there's your answer. Okay. Perfect. Perfect, perfect, perfect. All right. Excellent. Then we can move forward. Okay. Here we're saying calculate with decimals. Addition and subtraction of decimals, multiplication and division of decimals. Okay, so that's pretty straightforward. It's not too challenging. Okay, it's pretty much the same as whole numbers. You just need to align your decimals and you should be fine. Percentage, the word percentage simply means out of every 100. Okay, just means out of 100 you got 60%. Okay, all right, that's all that percentages is out of 100. Okay, that's all you need to remember. Okay, right. Then when we say 30%, we really mean 30 out of every 100. Okay, all right, all right. I'm sure you guys get the point there. Then percentage, need to know relationship between decimals, the relationship between fractions and percentages, converting a decimal or fraction to a percentage, converting a percentage to a decimal or fraction, expressing one number as a percentage of another. Okay, right. All right, so that's what we know, expressing one number as a percentage to another. So this is all we need to know. Okay, but this comes naturally once we just do exercises. Okay, this thing is about practice, guys. The more we practice, the better off we will be. The more prepared we will be. And we will definitely pass if you put in the effort. Okay, so don't worry. We just need to practice and we'll be just fine. Okay, working with ratios. Ratios is a way of expressing a relationship between two or more numbers, which enable us to make comparison between them, to make comparison. All right, that's the primary thing. So if they say for every 3 girls we had 2 boys. Okay, we're comparing boys to girls. How many boys to girls did we have in the school? All right, every 3 we had 2. Okay, all right, that's what ratios are all about. Okay, then here we're talking about ratios and fractions. Okay, so here we'd be saying what is the total number of people involved here? It's 5 because we're saying 3 plus 2. So in every 5 people, all right, you get 3 girls and you get 2 boys. Okay, that's typically all that we're communicating. All right, that's typically all that we're communicating. When we now start to bring it into fractions, okay? Right, and on the 20, on slide 20, what are they saying? Working with ratios, sharing in accordance with a ratio. In business, we often encounter instances where ratios are used to share wealth, costs, assets, or debts. Okay. Then what I recommend there is, okay, you must just understand the size of the pie. What is being shared? How much parts are being shared? Okay, if it's 5,000 profits, that's the total share. Okay, then we say I get 3 out of 5, all right, and you get 2 out of 5. Okay, this makes a total of 5 out of 5 parts. Okay, then we obviously times to find out who gets how much. Okay, in a partnership, for instance, the partners must decide how much they will divide the profits. Okay, so here we use that type of example. This often refers to profit sharing ratio. Okay, referred to as profit sharing ratio. Okay, then proportions. Okay, we talk about proportions when two quantities increase or decrease at the same rate. This means the ratio of the quantities stays the same all the time. Okay? Stays the same all the time. All right. When an increase or decrease in one quantity leads to an increase or decrease in other quantities, we say the amounts are directly proportional. In other words, the amounts directly affect each other. They affect each other. All right. The change in one will result in the change in the other. Okay. Right. Right. Ratios are said to be in the same proportion if they share the same relationship. Okay. So in other words, if a 50% change increase in one, let's say, let's call it A, equals a 50% increase in B, okay? Then they're in the same proportion, okay? If a 50% increase, or should I say a decrease in A is equal to a 30% decrease in B, then they're not in the same proportion. When one quantity increases in the same proportion as the other decreases, or vice versa, all right, the proportion is known as inverse or indirect proportion. So in other words, what they're saying is if you have a 50% increase in A, but then you get a 50% decrease in B, all right, that is an inverse or indirect proportion, all right, or relationship. All right, an increase in A causes a decrease in B, basically. Okay, then finally here they're talking to rates. A rate is a fraction used to compare quantities of different things. Used to compare quantities of different things. Okay. Okay. So here, a rate is a fraction used to compare quantities of different things. Okay. Rates are used when we need to compare two quantities that are not measured in hours or amounts of petrol used in liters to travel a specific distance measured in kilometers. Okay, right. So that's the definition for rates. Okay. How fast was he traveling? Okay. How many liters per kilometer? Okay. Those are all rates. How much cooking oil to use per dish. Okay, those are all rates. Okay, so guys, that is your unit 2. That is your unit 2. That is your unit 2. Are there any questions or thoughts in relation to what we've gone over? Like I said, we will do exercises together when we meet next week, Wednesday. We'll cover the exercises. All right. So yeah, what I can say is that just open your book, practice, guys, practice, practice. Wherever you have questions, we can then tackle them together in class. Ask me, then we obviously engage and interact over those things. We then engage and interact over those things. Okay. All right. Perfect. All right. So today,